Hello and welcome back to the PortSwigger Academy SQL Injection series here on CTF Security. I am Olajide, and in today's video, we're going to learn how to determine database table information and retrieve the content of the table to obtain the username and password of all users in a Postgres database. If you find today's lab challenging, check out our previous lab videos where we provide detailed explanations about SQL injection, including its various types and how to identify and exploit these vulnerabilities. So without further ado, let's get started. Hello and welcome back to the channel. Now, as usual, we have our lab title and our lab description. And on the lab title, we have SQL injection attack listing the database content on non-Oracle databases. This is to illustrate that we will be dealing with a non-Oracle database in this lab. So the first thing I want to do is to fire up my text file for our documentation. So I'll quickly move into our working environment for this lab. Change directory to document. Inside the document, we'll move to PortSwigger / SQL Injection. And from the SQL Injection directory, we're going to create a new file and we're going to call it 05.txt since we're dealing with the 5th lab of the SQL Injection. And this is going to bring up the Sublime text editor in which we can impute our documentation for this particular lab. So the first thing we want to do is to give it a title. So we'll be having lab title. So let's call it SQL Injection Attack, listing the database content on non-Oracle database. Great. So the next thing we want to have is our lab description, and it says the lab contains a SQL injection vulnerability in the product category. So we have SQL injection. Let's have a column here. So we have that in the product category filter. So that is where we have our SQL injection. Great. The results from the query are returned in the application response, so you can use union attack to retrieve data from the database. That sounds interesting. So we're going to be having SQL injection type is union attack. In case if you're not familiar with this union attack, you can quickly check the video description for link to the previous labs where we discuss about different types of SQL injection and how you can spot them and exploit them. So the next thing we have is so we have the result from the query are returned in the application response, so you can use union attack to retrieve data from the table. The application has a login function, and the database contains a table that holds usernames and passwords. You need to determine the name of this table and the columns it contains, then retrieve the content of the table to obtain the username and passwords of all users. To solve the lab, log in as the administrator. So our objective, let's call this lab objective, is to retrieve content of the table to obtain the username and password, or let's just pick it from here, to obtain great. So our lab objective is to obtain the username and password of all users. Then we are going to log in as the administrator user in order to solve the lab. Now that we have all the essential information from the lab description, the next thing we're expected to do is to access the lab. Now, while the lab is coming up, I have three tabs already open up right here. The first one is the SQL Injection cheat sheet, which contain examples of useful syntax that you can use to perform variety of tasks that often arise while performing SQL injection attack. I also have the PostgreSQL Injection cheat sheet already open, which is focused on performing SQL injection on PostgreSQL database. And lastly, I have the step-by-step guide on how to perform SQL injection union attack. Now let's go back to our web application. Now if you look at this application critically, you will see that every item on this web application has a header and a body. Now if you take a look at the body, it's more of like it is arranged in a table-like manner, and if I scroll to the end, you will see that we have the same structure all through the web application. Now if you take a look at our lab description, it says that there is an SQL injection in the product category filter. So let's try to refine our search. So let's say we go with corporate gift. Okay, we're just going to give that some seconds to load. Good. So now we have successfully filtered the items on this web application by the corporate gift parameter. Now if you take a look at the URL, you will see that we have the domain, we have the endpoint to be filtered, we have the parameter to be category, and we have our parameter value to be corporate gift. Now since this is an SQL injection that is being reflected on the page, the next thing we want to do is to see if we can break this application. So we're going to be introducing the single quotes into the product filter category. So let's actually try that out and see how the backend code reacts to this. So I'm going to impute one special character, which is the single quote, and I'm going to hit the enter key. Okay, so you can see that we have internal server error, meaning that this single quote actually broke the application in the back end. So this is an indication that we might have SQL injection present on this lab. So the next thing we want to do is to determine the number of columns required by this application. So if we're able to tell the number of columns that is being required by this application, it will help us to streamline our attack, so we know how many parameters or how many input value we're expected to inject into our payload. So in order to do that, you can do it actually in two ways. And if you go to the SQL injection union attack, we have two ways of determining a number of columns required. We have the first one to be the use of order by, and we have the other to be the use of series of union select statement. So since this is the simpler one, we're just going to be sticking with the first one. So what I'm going to do is to copy this payload in here, and let's go to our web application. I'm just going to add that to the end of the request. Sorry about that. Okay, great. So let's just paste in there. So we have category equals to corporate gift, then we have our single code, then we are ordering by 1, and if we hit the enter key, you notice that the application is going to sort the items, that is the title of the item, in alphabetical order. You can now see that we have C, then we have another C, we have the folding gadget, there is no I in theme. So if we are sorting by 2, it's going to sort the second item here, which is the body. But let's just see how it reacts to that. So we have our first order by, which actually worked correctly. So the next thing we want to do is to order by 2 and see what happened. Okay, great. So you can now see that we are sorting by body. So we have alert to be the first word here. We have the folding, we have all been there, Do we have any other one? So we have, you need never look anyone in the eye. So that is the order in which the item on this page is being sorted. So let's see if we have 3 columns. So if we have an error, it will be an indication that we just have 2 columns. So you can see that there's an error if we sort this application by 3 columns. So the order is, when you have an error, you just subtract 1 from the number of columns that you have. So this is 3 minus 1. This is an indication that we have 2 columns. So we have determine number of column. So number of column is 2 columns. Okay, great. So the next thing we want to do is to ensure that these 2 columns support the string data type, since we are going to be extracting the information in string data type. So in such scenario, what we need to do is to just refine the payload. So if we go to the payload, instead of having quote other by, okay, let me just put it in here. So why not have a single quote? Then we use the union attack. So let's have union select. Then we just put in a random string. Let's use R007. Then let's have the other one to be Olajide. Since we have 2 required columns, and then we comment every other thing out on the page. So let's see if this reflects on the page. I'm just going to paste that in here. Okay, do we have something wrong? Is there anything wrong? Oh, okay, it's supposed to be a space here. Then we have a comma after the first string, and let's see what happens. All right, great. So if you scroll down, you see that the 2 string that we have on our payload, which is the R007 and the Olajide, get reflected on the page, which indicates that the 2 columns that we have here that is being returned support the data type string. So if you want to actually confirm this, you could change one of these to possibly an integer and see how the application reacts to that. So let's actually do that. So I'm going to change the Olajide to 1, and when we run, you see that we're going to get an internal server error. So we've confirmed that the application support the columns support, let me just put this in capital letter, the columns support string data. All right, great. So the next thing we want to do is to refine this payload in order to get information about the database. So we need to know what kind of database is running on this application. Probably is an Oracle database or a MySQL database or Postgres or any other kind of database that might be existing in the back end of this application. So in order to do that, let's quickly go to our cheat sheet. And from the cheat sheet, if you scroll down, you see the part or the section that says database version. So we have different ways of checking for database version. So if you are dealing with MySQL, this is the payload for that. If you are dealing with Postgres, if you are dealing with Microsoft, if you are dealing with Oracle. Now, since from the lab description we have on non-Oracle database, so we are not going to be using an Oracle database payload. So let's go back to the cheat sheet. And from this cheat sheet here, the first one we're going to try is the Microsoft, which is this one. So probably it is a Microsoft database. We're yet to know. So the next thing we do is copy the previous payload we used. We can paste that. Sorry about that. I'll just copy that again. All right, great. So I'm going to paste it, and we're going to call this getting database version and type. All right, cool. So we need to refine this payload. So instead of putting our string data here, we're going to replace one of these string data by this payload. So let's grab this one and let's just place it in here. All right, cool. And we're going to have a comma here, and I forgot to put a comma here. So let's see what happens when we use this payload. So let's head to our application. We're going to edit the URL and we insert our payload. Okay, we got an internal server error. So let's use another payload, which is the PostgreSQL. So I'm going to copy and oh my god, that was an error. I have double select statement. So I'm going to do that again with the Microsoft SQL. Just to be sure. Paste, and we're going to execute. Okay, so we have the internal server error. So let's try with the Postgres payload. We need to grab that here. Okay, so let's just pick only this one since the select statement is all the same. I'm going to paste that in here. All right, great. So we're going to copy and we head to our application and we're going to insert our payload. All right, great. So you can see that this actually work on this application, and if you scroll down, you can see that we've successfully extracted the database name, so I beg your pardon, the database type and version of this particular web application. So let's just remove this text file so that we just have just the database version information. So to do that, all we have to do is to just remove the corporate gift value here, and I'm going to reload the page. So you can see that we just have a PostgreSQL 12.18, Ubuntu 12.18. We also have it to be 8664 PC Linux GNU compiled by GCC, and this happens to be 64-bit. So now we've successfully gotten our database type and version. So let's just put that in here, paste it in here. All right, cool. So now that we have the information regarding the database version, now we know what kind of payload we're expected to supply to this application. And the first thing we want to do is to be able to know what is the name of the database. So if we're able to get the name of the database, we'll be able to get the table. Then from the table, we'll know how many columns exist in the table and the columns that are peculiar to the username and password in order for us to be able to extract all the username and password from the database. So in order to do this, let's check out our cheat sheet. And if you scroll down, I'm looking for something that says listing database. Do we have anything like that? Okay, great. Okay. Postgres database name, Postgres list database. So we're looking for something like this. So what we need to do is to just refine this payload here. So we have list database. All right, cool. The payload to list database is select dat name from pg underscore database. So we need to incorporate this into our payload. So let's bring up this payload, and I'll just paste this down here. So if this is the payload, what we'll do is we're going to replace this. So let's have from database name from pg database. I'm going to copy that, and I'm going to just put it after the select statement, and let's paste this in here, and let's see how the application is going to react to that. So again, just replace that in here, and remember to supply the double hyphen in order to comment out other part of the query. Okay, so we have an error. So the reason we actually have an error is because the application is requiring 2 columns. If you take a look at the initial payload that we used to test this application, it requires 2 columns of information, but we are just supplying just one, which is the database name. So in order to solve this, what I'll just do is to add one more, and I'll call this null. I'll just call it null, and let's see what happens. Don't forget the double hyphen. Let's see how the application is going to respond this time around. Okay, great. So you can see the name of all the, let me just see, can I increase this a bit? All right, great. So you can see the name of all the databases on this web application. We have the template 0, the Postgres, the academic lab, and we have the template 1. The next thing we want to do is to list all the tables in the database. So to do that, I'll go to our PostgreSQL Injection cheat sheet, and here we have the Postgres list tables. So let's quickly grab that, and let's call this list database table. All right, this is the payload, but we need to still modify the payload to something like this. So I just want to copy this and then make sure that we have the select information schema from this database. Okay, we can actually do with this one, and we can just add up union, and then make sure that we're selecting two columns, which is the table name and null from information underscore schema dot tables, and let's see if this works. Okay, we have an error. Okay, I forgot to put the double hyphen to comment out other part of the query. All right, great. So you can see that we've successfully extracted all the tables within the database. Now what we're looking out for is the username table, because if you go to the lab description, it says the application has a login function and the database contains a table that holds the username and passwords. So which is exactly the table that we are looking for. Now if you scroll through, we should be able to see a particular table that carries users, probably to be named the users table. So I'm going to find, let's call this user. So we have first users. The first user we have is user defined types, which is a table. And let's see if we have others. We also have pg statue user sequence. We also have mapping, user mapping, pg exact. Okay, I think I found one. So you can see one here which says users underscores, then we have this random text. So this might look actually interesting. So I'm just going to put this here, just to indicate the table name. All right, great. So now that we have the table name, the next thing we want to do is to list the columns that exist on this table. So in order to do that, we're going to go to our payload and we'll go to the section that says list columns. List columns. All right, great. So we have PostgreSQL list columns. Quickly grab the commands. So I'm going to paste the command, and what we need to do is to just modify the payload. And in order to modify the payload, we have just one column being returned as usual. I'm going to add one more, and then I'm going to make sure that I comment out the rest of the query, and then we append our union keyword here. All right, great. So I'm going to copy, head to our web application, and we're going to insert our payload. Okay, so we might have an issue. So it says, oh, okay, so we have database table. Sorry about that, I forgot to insert our database table information. So what we need to do is to grab the table name and insert this here. So we're going to try that one more time. Okay, so I'm going to paste. All right, great. So now you can see that we have 3 columns on this particular database table. We have the username with the random string. We have another column called email, and we have another column called password with also underscore some random strings. So the next thing we want to do is to extract all the data inside these particular columns. And that is what the last section of the lab says. It says you need to determine the name of the table, which we have done, and the columns it contains, which is exactly what we have here. These are the list of the columns that the database table contain. And then lastly, retrieve the contents of the table to obtain the username and the password. Now, since we have 3 columns and we know that our application can only support 2 columns, so what we need to do is to concatenate these 2 columns. Let's quickly do that. If we go to our payload, we're going to look for something that says list content or list information from a database. Let's start from the top. Version, list users. Okay, this should work. It says Postgres list password hashes. So if we're able to combine the username and the password field, then we specify the name of the table, we should be able to extract the information from that particular table. So let's grab this and let's head to our documentation, and we're going to call this list table content. All right, great. So what we need to do is to also modify this. We append the union keyword, and we make sure that we are actually extracting 2 columns. But before we do that, I need to grab the names of the columns that we have here, which are 3 columns, and let's just put it in here as the output. All right, great. So for the username, this is what we're going to be using in place of that. I'm going to copy. For the password, this is what we're going to be using. For the database name, this is what we're going to be using. Okay. There should be a space here. I'm going to paste this here. And not forgetting our double hyphen in order to terminate or to make other part of the query irrelevant. So let's go back into our web application and see if this will actually work. Let's work. All right, great. Wow, interestingly, you see that we've successfully extracted all the username and password within this particular database table. So we have the winner, we have the administrator, and we have the Carlos. So Carlos, I beg your pardon. So we're going to copy the administrator username and password. Okay, so in case let's say we want to actually see their email address, you could actually modify this, and let's just repeat this. So instead of actually viewing username and password, we could replace the password column with the email address. All right, great. So let's grab this and let's try to insert that here. And paste. And let's see what happens. All right, great. So you can see that we do not have email addresses for each individual. What we just have is their username, and that is why this section is actually empty. So let's just go back in order to display just the username and password. So to solve the lab, lastly, to solve the lab, log in as administrator user. So since we have the administrator user credential, we can actually log in as administrator. So let's go to the my account, and from the my account section, we're going to use the username to be administrator, and the password here I'm going to copy and I'm going to paste. So let me just don't save. Your username is administrator, meaning that we have actually logged in as administrator. So let's go to the home page. Okay, so you can see that we have an indication. Congratulations, you solved the lab. And this marks the end of the part 1 of this video. So guys, stay tuned for the part 2 of this video, where we are going to be scripting the same attack using Python programming language. Thank you guys for watching. If you find this video helpful, please like, share, and subscribe for more content on SQL injection and other cybersecurity topics. See you in the next video.